In this video, we're going to be looking at demand and elasticity. The economic advisor of a large tire store proposes the following demand function. D of P equals 1800 divided by P minus 40. Okay, where D of P is the number of tires of one brand and size that can be sold in one day at a price P. Okay, so our first question says, recalling that demand must be positive, what is the domain of this function? Okay, so if we know that demand must be positive and this is our demand function, then we know that D of P must be positive. Okay, so if D of P must be positive, we look at this function that we have, 1800 divided by P over 40, or 1800 divided by P minus 40, that must be positive. Okay, so if we look at this and we could see that we can't set the numerator equal to 0 to figure out anything, but the denominator, we have a point there we have to look at, which would be 40, because if you have a 40 here, then the denominator would be equal to 0. So we need to see what happens around 40 to make our decision on whether or not what's happening around there to see what the P is. So we've got 1800. And we divide, and let's plug in a 41 into the bottom. So it would be 41 minus 40, which would give us positive 1800. Now, if we go less and we do 39 minus 40, that's one less than the 40. That's a negative value. So you can see if we're left of 40, those are negative values, and if we're right of 40, those are positive values. Okay, so on a little number line, you could look at this and say, okay, for D of P at 40, over here is negative values, and over here is positive values. So we have to be bigger than 40 and not include 40. So that's going to be P is greater than 40. And if you want to write it in interval notation, it would be 40 to infinity, because there's no upper limit. Okay, look at the next question. It says, according to the model, how many tires can be sold in a day at a price of $60 per tire? Okay, so what we're going to do there is plug in a 60 into D, so D of 60. Okay, so we'll plug in, let's see, that's 1800 divided by 60 minus 40. Okay, and if you do that, you get 90, so that's 90 tires. Okay, that was B. C, find the elasticity function on the domain of the demand function. Okay, so the elasticity function is this. Okay, it's E of P. Okay, and that's equal to, I'm going to write it in a couple different ways here. The derivative of D with respect to P times P over the D function. Okay, so it's the D function. Now I'm going to write it in a slightly different way. I will write this is equal to, and it will be the derivative of D, so I'll put D prime of P, and then P is just P, and then D is just the function D. Okay, so that's the elasticity function, the derivative of the demand function on top with the extra P being multiplied, divided by the original demand function. So let's figure out what the derivative of the D function is, demand. So we look at the demand function, it's this, so D prime of P. Okay, we'll do the quotient rule here. So it's the low one, P minus 40, times the derivative of the top, derivative of 1800 is 0. Okay, minus, and then it's the 1800 times the derivative of this one is just a 1. Derivative of 40, negative 40 goes away, and derivative of P is a 1. Oh, it should have been a 1. Okay. Okay, and then on bottom, we will have the denominator squared, so P minus 40 squared. Okay, so it's the quotient rule, so that's going to be, this term is going to zero out, this is going to become negative 1800, and on bottom we get P minus 40 quantity squared. Okay, so that is the derivative. Okay, so I go back over here to this elasticity function, and I plug in the derivative, which is negative 1800 divided by p minus 40 squared, okay? And then I multiply by p, so that's times p, and then I divide by, and that's going to be d of p, which is the original 1800 divided by p minus 40. Okay, so I'm going to flip that fraction up, bring it up to the top. I'm going to put this p over there with that 1800. So it'd be negative 1800p, bringing that p in, divided by p minus 40 squared. Now I'm going to flip this fraction and put the p minus 40 on top, and I'm going to put the 1800 on bottom. So I flipped it and multiplied it. Okay, and you can see a few things cancel. This p minus 40 cancels, and it brings this exponent down to a 1. And this 1800 cancels, leaving a negative and a p. Okay, so that's going to be E of p, this is my elasticity function, is equal to negative p divided by p minus 40. Okay, you could also write that as a little different. You could put the negative on bottom. So positive p, change the sign of these two, so it'd be positive 40 and then minus p. Okay, this is the one I'm going to use, but you could use either one. Okay, so that's the elasticity function. Okay, next question. For what prices is the demand elastic or inelastic? Okay, so by definition, it's elastic if E of p is between negative infinity and 1. So let's write that down on D. So to be elastic, using the elastic function, we know that it's got to be between negative infinity, and that's E, the E function, and negative 1. Okay, if it's bigger than negative 1, then it becomes non-elastic. Okay, so we look at this function here, the E of p, okay, and we say, what is happening to this? And remember, p has to be greater than 40, right? That's what we learned on the first one. So if p is greater than 40, what's happening here? Like, try like a 41. Okay, so let's plug in the closest thing we can find to that. So if we do p, which is 41, divided by, and 40 minus 41, notice what we get, it's negative. Okay, but if we go bigger than that, if we go too much or less than the p-value, we would get a negative value, which we cannot do. But if we did, let's say we did 39 and minus 39, okay, then we would get a positive value, and that would be non-elastic. But we've got this that says it has to be bigger than 40, so this is always going to be elastic, because the value is always going to be between negative infinity and negative 1 of this with our p restriction. Okay, and now the last question. Okay, if the prices are raised from $60 to $62, what is the approximate percent decrease in demand? Okay, so first of all, it started at 60, so let's figure out what the elasticity is at 60. So we plug in that 60 into that function, so that's going to be 60 divided by 40 minus 60. That is 60 over negative 20. Okay, and that will be negative 3. So the elasticity at 60 is negative 3. Okay, now how much did this change? What percent did the price go up? That's the next thing we want to look. What percent did this go up? So to do that, we say it went up $2 out of 60. So 2 out of 60 gives you, if you divide that, 3.33, and that decimal repeats percent. Okay. So this is your percent change in what the prices were. Here's our elasticity at the time. To get what changed, or to get the approximate percent decrease in demand, we multiply these two numbers. Keep in mind it said decrease. That's going to be important in a second. Okay. Right now we're just finding the change, not the decrease. Okay. So we multiply these two numbers together. So it would be percent change. That's what I'm going to write here. Percent change is going to be negative 3 times 3.33%. Okay, and that's about negative 10. Okay, really close to negative 10%. Okay, now why I said keep in mind that it says decrease, because we got a negative 10 because it's decreasing, but the problem already said decrease. So you're going to need to use a positive value. So it decreased by, not by negative 10%, it decreased by 10%. Okay, so that's what the demand happened. If they raise the prices by $2, then the demand for the tires decreased by 10%. And that's it.